Bismillahirrahmanirrahim. I'm Zahur Islam, and today my lecture is about antioxidant. This is lecture number 3 about the pharmaceutical excipients which are used in different type of formulation. So that is antioxidant. Now what is antioxidant? So antioxidant can be defined as an antioxidant that is a molecule that inhibits the oxidation of other molecule, or you can say that oxidation as a chemical reaction that there is a transformation of electrons or hydrogen from a substance to an oxidizing agent. So antioxidant are those substances which are responsible to prevent the oxidations. Now what are the ideal properties of antioxidant? Why antioxidant? They are used in different type of formulation. So the first one is it must be effective at a low and non-toxic concentration. So it means that antioxidant, they must be effective at a low concentration and it should be non-toxic. When we are going to prepare or formulate any dosage form, so we are using different type of antioxidant to avoid the oxidation. The second one is to stabilize. It must be stable and effective under normal condition of use over a wide pH and temperature range. This is another ideal property of antioxidant, that it must be stable and it must be effective under normal condition of use over a wide pH and temperature, and how much the temperature or pH, if it go up and down, but here it will must maintain its stability and its effectiveness. So the another ideal property of antioxidant is it must be soluble at the required concentration. So this is the third ideal property of antioxidant. So it must be soluble at the required concentration. That to which concentration that is required for that, so it must be soluble. It must be compatible with a wide variety of drugs and pharmaceutical excipient. So it must be compatible. So whenever we are going to formulate any things or any for examples, it may be in the form of solid dosage form or liquid dosage form. So antioxidant, it must be compatible with that particular drugs and the pharmaceutical excipients. So it must be free from objectionable odor and objectionable taste. This is the fifth one ideal property of antioxidant. It must be free from objectionable taste, and it must be free from objectionable odor. It should be colorless in both the originals and oxidized form, and it should be non-toxic both internally and externally at the required cost, and it must be reasonable at cost. And the most important property of the antioxidant is, so it must be unreactive. It doesn't absorb, penetrate or interact with the container or closure. So we know better, inshallah. The next lecture we will talk about the container and closure. These are the examples of antioxidants. So different type of antioxidant, they are used in various formulation like BHT, butylated hydroxytoluene, BHA, butylated hydroxyazole, the third one is sodium sulfite, ascorbic acid, etc. So vitamin C, this is also one of the best antioxidant. So it will prevent your product from the degradation. So in order to avoid the degradation and different pharmaceuticals preparation. Another excipient that is called sweetening agents. Sweetening agents, they are employed in the liquid formulation designed for oral administration, specifically to increase the palatability of the therapeutic agent, so it can be easy for the patient to take it. So especially this is palatable, the patient become able to easily he or she can take it. So sweetening agents are employed in a liquid formulation especially, and liquid formulations like syrup suspension, so they are designed for the oral administration, especially in order to increase the palatability of the therapeutic agent. For example, sucrose, saccharine, aspartame, and sorbitol. So these are the common sweetening agents which are used in various kinds of pharmaceuticals, like liquid formulations. What are the uses, applications of sweetening agent? So the main sweetening agents employed in oral preparation are sucrose, liquid glucose, glycerol, sorbitol, saccharine, sodium, and aspartame. Aspartame is an artificial sweetening agent. The use of artificial sweetening agent in formulation is increasing because the use of sugar in oral formulation for the children and patients with diabetes mellitus is to be avoided. So for example, let's suppose if you are going to manufacture a products that contain sugar, so it cannot be given to the diabetic person, a person who has diabetes, so it should be avoided in that condition. It's especially the use of sugar in oral formulation for children and patients with diabetes mellitus, it must be avoided. Another excipient, that is flavoring agent. So now what is flavoring agent? So flavoring agent, they are usually added to the formulation in order to increase the patient acceptance. How to increase the patient acceptance? Mean the patient become able to accept it. Different type of flavors they are used in various pharmaceutical preparations. So the four basic taste sensations, they're salty, sweet, bitter, and sour. So it is being proposed that certain flavors should be used to mask these objectionables, you can say the specific taste sensations. So then the patient become easy for the patient to take it. These are the example. So chloride, this is flavoring agent, fluoride, citric and syrup, glycerine, rose oil, orange oil, and menthols, which can be taken from the mentha pepareta. So these are flavoring agents that depend upon on you that what type of flavoring agent they are used. Coloring agent, these are coloring agents are a pharmaceutical ingredient that impart prefer to the color to the formulations. Why we are going to import color to various formulations? In order to enhance the, you can say, it is used for aesthetic purpose. So there are two types of coloring agents they are used. The first one is natural and the second one is synthetic. For example, white titanium dioxides, they are white in colors, and you can say white titanium dioxide, while blue, brilliant blue, indigo, carmines, the red one is amaranth, carmines, the fourth one is yellow, saffron, the fifth one is green, and the sixth one is brown, caramel. So these are different type of coloring agents which are available in pharmaceutical industries, so they depend upon on you that what type of formulations you like. The solvent. So we know that solution is the combination of solute and solvent. So it becomes a homogeneous mixture of two or more than two components. So when there is low amount of a solute, so you can say it's said to be dilute solution. When there is high amount of a solute, so it is said to be concentrated solution. Now here the solvent is a substance that can dissolve a solute, a chemically different liquid, solid or gas, resulting in solution. So a solvent is usually a liquid, but it can be also solid or gas. A solvent never change its state, forming a solutions. So different type of solvents they are used. For example, you can say Solvents can be classified into different categories. Solvents can be broadly classified into two groups. They may be polar or they may be non-polar. So normally the solvation of solvents depend upon its classification, and generally polar solvent dissolve polar compound best, and non-polar solvent dissolve non-polar compound best, as we know that. So this is universal truth that like dissolve like. Polar will be dissolved in polar solvents and non-polar will be dissolved in. For example, we can say naphthalene or camphor, which is non-polar in nature, so it cannot be solubilized in water.